And so what we're going to do is we're going to take this first proportion. And this first proportion, x over t and t over z. If we take this proportion and do the cross product, we're going to get t times t is equal to x times z. T times t is t squared and is equal to, and then the product of x and z. If I wanted to solve for z, if I wanted to solve for t, then what I could do is take the square root of both sides. The square root of t squared is just t, and the square root of the products x and z is just simply that. Well, this is the geometric mean. So if we look, we see that t is the square root of the product of these two numbers. That's the geometric mean. So what we've seen is t is representing the length of the hypotenuse. Of the altitude. T is representing the length of this altitude. X and z are the two pieces of the large triangle's hypotenuse. So we can see that solving this proportion, the length of the altitude is always the geometric mean of the two pieces of the large triangle's hypotenuse. And that's exactly what this first corollary says. It says when an altitude is drawn to the hypotenuse of a right triangle, meaning when this happens, when this diagram happens, the length of the altitude, t, is equals the geometric mean between the segments of the hypotenuse. This between the segments of the hypotenuse, that means between the two pieces of the large triangle's hypotenuse. That's what it means. And so that's exactly what we've shown. T is the geometric mean of these two pieces. That's the first corollary. The second one comes from item 3. Check this out. In item 2, we use properties of similar triangles to justify that this proportion is true. Solve the proportion for u. Well, if I did that, the cross product is u times u equals x times p. U times u is u squared, and x times p is just simply xp. Now, if I want to solve for u, that means I need to get u completely by itself. I need u equals something, not u squared equals something. So I need to take the square root of both sides because that's the inverse operation of squaring a value. So I get that u is the square root of xp. Well, once again, we have this square root of the product of two values. That is the geometric mean of two values. You take their product and then take their square root. So what we see is, when we look at this proportion and solve it, we see that u, or the length of the triangle's leg, of the large triangle's leg, is the geometric mean of x and p. P is the large triangle's hypotenuse, and x is the portion of that hypotenuse that is adjacent to that leg, in this case u. So the length of the large triangle's leg is equal to the geometric mean of the hypotenuse and the piece of the hypotenuse that's adjacent to that leg. That's exactly what our second corollary says. It says when the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean. So each leg, I'm talking about u and w. Each leg is the geometric mean between the hypotenuse, the entire thing, which was p, and the part of the hypotenuse that is adjacent to the leg. So we were just talking about x. So notice how it says to each leg. So that means if I want to use the second corollary to find u, I know that u, that length of the leg, is the geometric mean of the entire hypotenuse p and the portion that it is adjacent to. So that would be x. However, if I wanted to find this leg, because look at the corollary, it says when an altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the part of the hypotenuse that's adjacent to the leg. So this also works for over here for a w. So w, the length of that leg, is equals the geometric mean of these two values, the hypotenuse and the piece that it is adjacent to. So in this case, we're talking about z. Now, these corollaries are just shortcuts because if you look at item 4, it says write and solve the proportion that can be written from the corollary 2, but we're using W. That is this leg. Well, what we're going to do is we're going to compare the medium triangle and the large triangle. And we're going to compare the hypotenuses and the long legs. So we're going to look at long legs and the hypotenuses. So I got my proportions set up. Comparing the medium triangle and the large triangle, we're going to compare the long legs and the hypotenuses. The long leg of the medium triangle is W. The hypotenuse of the medium, oh, I apologize. I'm sorry. The long leg of the medium triangle is Z. Is Z. The hypotenuse of the large triangle, that one is W. The long leg of the large triangle is W, and the hypotenuse of the large triangle is P. So this is the proportion, and all I'm using is similar triangles and comparing corresponding parts. That's it. When I take the cross product, I'm going to get that W squared is equal to Z times P. When I take the square root on both sides, I get that W is equal to the square root of Z times P, meaning W is the geometric mean of Z and P, like I just said. This is the geometric mean, this leg is the geometric mean between these two values, the entire hypotenuse and the portion of the hypotenuse that that leg is adjacent to. And this is the proportion that showed us that. All of this to say, these corollaries are shortcuts. What they allow us to do is to simply jump to this point and over here jump to this point rather than setting up this proportion, taking the cross product, simplifying, taking the square root, and then getting here. The corollary is just a shortcut to this. Same thing here. Rather than doing the proportion, cross product, solving for your variable, and then getting here. But what you have to understand is that these proportions always work. So if you don't like these corollaries, then don't use them. Don't use the corollaries if you don't like them. Just simply use that these are three similar triangles. And these three similar triangles you will use to set up proportions and solve for missing side lengths. On the next page, it gives us this example, and you can walk through it. What I suggest that you do is, if you have a diagram that looks like this with the three right triangles, break it up into the three similar triangles individually. So I have the large right triangle, and that would be triangle FDE. I have the medium-sized triangle, and that would be GFE. And then I have this small triangle, and that is GDF. So, solving number one, or sorry, it says try these A. If y is equal to 2, so if this is 2, the length of segment GD is 2, and the length of x is 16, that's your altitude, solve for z. Well, this is the first corollary, and it says that this altitude's length, that x, it is the geometric mean of the two pieces of the hypotenuse, which are y and z. So that means 16 is the square root of 2 times z. And then you would just solve for z. How you would solve for z is I need to get 2z by itself. Currently, 2z is, we have the square root of that. So you need to do the inverse operation, which is squaring. So whatever you do to one side, you have to do to the other. And so we're going to square both sides, and 16 squared is 256. And then I'm going to divide by 2 on both sides, and we get that z is equal to 128. Now, if you didn't use the corollaries, then what you would have to do is you would look at these triangles, and you would have to fill in what you know. On the large right triangle, you don't know any of the side lengths. You don't know a single side length. On the medium triangle, you know that the short leg of the medium triangle is 16. You know that the long leg is z. On the small triangle, you know that the short leg is 2 and the long leg is 16. Now that I have this drawn, it is clear what corresponding parts and sides I have and what two triangles I'm going to use. I'm going to use my medium and my small triangle, and I'm going to set up the proportion. Long leg z to long leg 16, long leg to long leg, is equal to short leg to short leg, 16 to 2. When I solve this, I get 2z is equal to 256. Divide by 2 on both sides, and z is equal to, once again, 128. I don't care what method you use. If you want to use the corollary, this is how you go about it. Knowing that the altitude is the geometric mean of those two values. That's the corollary. If you just want to use the fact that you've got 3 similar triangles and then you plug in what you know and set up a proportion, then do that. Whichever way you want works for me. This next one, Part B. Part B gives you a different set of information. Tells you that this is 18 and that z is 45. So I'm going to do it both ways once again. If you use the corollary, I know that 18 is the geometric mean of y and 45. So we're going to square both sides, and that means that 18 squared is 324 is equal to 45y. We're going to divide both sides by 45, and y is equal to 7.2. That's using the corollary, knowing that the altitude's length is the geometric mean of the two pieces of the hypotenuse. If you want to use the similar right triangles, then here's my medium triangle. It is E, G, F. Here's my small triangle. It is G, F, D. And I'm going to plug in what I know. I've got that the length of FG is 18. The length of DG is y, and the length of EG is 45. So I can see that my proportion is going to be 45 over 18 is equal to 18 over y. When I take the cross product, I get 324 is equal to 45y. Divide both sides by 45, and I get that y, once again, is equal to 7.2. So you choose which way you want to solve these. Either use the corollaries or just keep using similar triangles. You're going to get the same answer both ways. In class, we will go over questions or concerns that you have on the homework, but it just boils down to setting up proportions of these similar triangles.